Okay, welcome to the 8.3 video. We're actually starting with the last example of 8.2. This is the word problem example 6 on the last page of your 8.2 notes packet. And remember, 8.2 is about using the quadratic formula, so that's kind of a hint that this word problem is going to probably use the quadratic formula. And in order to use the quadratic formula, that means we're going to have a quadratic equation, which means we should end up with an equation that has an x squared. So let's start by understanding the problem, and in order to understand it, we want to read it at least once, usually twice. At a local university, students often leave the sidewalk and cut across the lawn to save walking distance. Given the diagram below of a favorite place to cut across the lawn, approximate how many feet of walking distance a student saves by cutting across the lawn instead of walking on the sidewalk. So if you can picture this, imagine that the sidewalk keeps going. So this is probably, there's a building over here, and this is the door to the building. And then there's another building over here, and here's the door to the building. And you can either go between the buildings by walking along the sidewalk, or by cutting across directly from door to door. Okay, so what we end up with here is that these two sidewalks meet at a perpendicular or a right angle, giving us a right triangle. And for a right triangle, we know we can compare the leg lengths and the hypotenuse length. So the legs of the triangle, we have x and x plus 20. And it doesn't matter which legs are x and x plus 20 as long as you label those as your two legs. And the hypotenuse has a length of 50. And we know that the relationship for this right triangle is the Pythagorean theorem. And remember, the Pythagorean theorem states a squared plus b squared equals c squared, where c is the hypotenuse, the side that's across from our right angle. So 50 is our c. And then we have a and b, and it doesn't matter which one is a and which one is b. Those are just the two legs. So we want to set up our Pythagorean theorem. So we have our first leg squared plus the second leg squared equals the hypotenuse squared. So notice we'll have an x squared. This is a quadratic equation. So we want to simplify x squared plus, we have to FOIL this, x squared plus 20x plus 20x plus 400 equals 2500. Collecting like terms, 2x squared plus 40x plus 400 equals 2500. And here we have a choice, because we know now 3 ways to solve quadratic equations. We can subtract the 2500 from both sides and see if we can factor it. And that's the same setup that we would need for the quadratic equation. Or we can subtract 400, and then we would be set up to complete the square. Now, usually what I'll try first is to factor it, because that's our easiest method. And since that also sets us up for a quadratic formula, that would be my second step. Completing the square is not the most common way to solve quadratic equations, unless it's very clear that we would have a perfect square trinomial. So we're going to subtract 2500 from both sides, and we end up with 2x squared plus 40x minus 2100 equals 0. And from here, I can say, okay, 2 times 2100, does it factor into something that gives me 40? And I don't see anything off the top of my head, but I do notice that all 3 of these numbers are even, which means I can divide everything by 2 and get an equivalent equation, a simplified equation that has the same solution. So x squared plus 20x minus 1050 equals 0. Okay, just by dividing everything by 2. Now, I can't think of 2 numbers that multiply to 1050 and subtract to 20, so I'm going to go ahead and use the quadratic formula, where a is 1, b is 20, and c is negative 1050. I'd like you to pause the video now and see if you can finish this problem. Press play when you're ready. So hopefully you've given this a try. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Negative 20 plus or minus the square root of 400. Negative times a negative is a positive 4200 divided by 2. Negative 20 plus or minus the square root of 4600 divided by 2 equals, okay, so from this point we would split this into the two cases, the plus case and the minus case, and substitute that into the calculator. You can continue to simplify by hand, but that square root of 4600 is not a perfect square, so at some point you will have to put this into the calculator. So we get negative 20 plus the square root of 4600 divided by 2, and negative 20 minus the square root of 4600 divided by 2. Into the calculator it goes, and you should end up with 23.9, scoot the page over, or negative 43.9. Well, remember, this is asking us for a distance, right? If I want x, x is a distance. So it can't be negative, so this is extraneous. So I know that x is 23.9, which if I go back to my triangle here, that means the distance here is 23.9 feet. This was 50 feet. And then this other side, the leg of our triangle, is 23.9, which was x, plus 20. So this side is 43.9 feet. And then we want to make sure we've answered the question. So the question is, how much does the student save by cutting across the lawn instead of walking on the sidewalk? So if the student had walked on the sidewalk, it would be 23.9 plus 43.9 feet. So sidewalk distance would be 23.9 plus 43.9 for a total of 67.8 feet. Whereas if you cut across the diagonal, it's 50 feet. So how much did she save? Well, 67.8 minus 50 is 17.8. So you save 17.8 feet by cutting across the lawn instead of walking on the sidewalk. All right, let's take a look at the 8.3 notes packet. Now remember, you don't have to print the 8.3 notes packet, but if you're not printing the 8.3 notes packet, then you need to be taking these notes in your notebook. And I will be checking, not while we're doing virtual learning, but when we return on the stamp sheet, completing the notes is part of your stamps. So make sure you're taking notes and you're putting it somewhere organized that you'll be able to find it later. Okay, so the 8.3 notes. In 8.3, we're looking at solving quadratic equations. This is different than what we've been doing so far because we might not have it already in quadratic form. And so we're using what we call quadratic methods. So that is factoring, completing the square, as well as the quadratic formula. So let's recall, what is the quadratic formula? Hopefully you know this by heart. If not, keep singing the song that's posted on the topics page, and that will help you memorize it. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So when we're looking at example 1, now this equation does not look to be quadratic. So that's what we mean by using quadratic methods, is I need to somehow turn this equation into a quadratic equation, which means somehow this needs to turn into a squared. So what we're going to do is we're going to use substitution. I could isolate the radical, use the power rule that we looked at in the last chapter. However, since I want to use quadratic methods, what we're going to do is we're going to say, what if this middle term was something else? Let's call it a. So if a is the square root of x, then a squared would be the square root of x squared, which is x. So by substitution, we're going to substitute from x to a, and this becomes a squared minus a minus 6 equals 0. That is quadratic. From here, we want to use our quadratic methods. Always try factoring first. What two numbers multiply to -6 and add to -1? Well, if we look, -6 and -1 is 3 and 2, where the 3 is negative. So this becomes a minus 3 times a plus 2 equals 0. And then we say, okay, nice, we've got it factored. It's already set equal to 0. So now we can set each factor to 0. A minus 3 is 0. A plus 2 is 0. So plus 3, a is 3, minus 2, a equals -2. Now we didn't use the power rule, and we don't have any denominators, so we don't have to check for extraneous solutions. However, notice our question was in terms of x, so now we have to substitute back in from a to x. So we're going to use the value that we defined. We defined a to be the square root of x, and we're going to substitute these values of a into this value of x. So we say a equals the square root of x. That means 3 is the square root of x. And now we do have to use the power rule, which means we need to check our solution to find that 9 equals x. And we know we're going to need to check. And we also have our second solution, substituting in the value of a. -2 equals the square root of x. Use the power rule. 4 equals x. Again, we use the power rule, so we need to check our answer. So how do we check our answer? We substitute it back into our original equation. So we say 9 minus the square root of 9 minus 6 might be equal to 0. 9 minus 3 minus 6. 9 minus 3 is 6. 6 minus 6 is 0, so it checks out. X equals 9 works. Here, our second answer, x equals 4. 4 minus the square root of 4 minus 6 might be equal to 0. 4 minus 2 minus 6. 4 minus 2 is 2 minus 6. -4 does not equal to 0. So that is an extraneous solution. Therefore, our answer is that x equals 9. So notice we didn't have to check our solutions because of the step of substitution. We have to check our answers because of the power rule that we used when substituting back. Let's look at another example. In example 2, again, we start with something that does not look to be quadratic. However, it might lead to something that's quadratic. So when I'm looking at this, I say, hey, I see fractions, I see an equal sign, so my first step is going to be to clear these fractions. And in order to clear the fractions, remember we need an LCD. So pause the video now, see if you can find the LCD. Our LCD, looking at our denominator, should be x times the quantity of x minus 2. So that's what I want to multiply all of these fractions by. X times x minus 2 over 1. So if I distribute that to each term, x times x minus 2, x times x minus 2, x times x minus 2, the x minus 2's cancel out, so we have 3x squared minus, x reduces, x plus 1 is in parentheses because it's a binomial, x plus 1 times the quantity of x minus 2 equals, and they both cancel, so just 6. Clearing the fractions, I should not have any denominators left if I used the proper LCD. So now I need to distribute here. 3x squared minus, I'm going to leave it in parentheses so that I don't miss a negative. X squared minus 2x plus x minus 2 equals 6. Distribute that negative. 3x squared minus x squared plus 2x minus x plus 2 equals 6. And then we'll collect like terms. Now we could have collected like terms here, but either way we'll have to collect like terms here. So collecting like terms, we have 2x squared minus x plus 2 equals 6. And then again we have that decision to make. Am I going to subtract the 2 over to complete the square, or subtract the 6 over to try factoring or quadratic formula? Usually try factoring first. So we're going to subtract 6, 2x squared minus x minus 4 equals 0. So I'm looking at this. Are there two numbers that multiply to -8 and add to -1? Well, 8 is 1 and 8, 2 and 4, and that's it. So it doesn't work. I can't factor it. If I tried completing the square, I would have fractions. So our easiest way to solve this is quadratic formula. A is 2, B is, make sure you keep that -1, C is -4. Pause the video and try solving this. All right, so we should have x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. Negative of a negative is positive, plus or minus the square root of -1 squared becomes positive. -4 times 2 is -8, times -4 is plus 32 over 4. So we have 1 plus or minus the square root of 33 over 4. And I've just realized I actually dropped a negative here. So that's a 2x minus x should be positive, 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 positive. Okay, so when I collected like terms here, I dropped a negative, so I went through and I fixed my signs. All right, so this is my two solutions. Now, I'm not asking for a distance, so I don't need to calculate this exactly unless I'm asking for the estimate. So this is my exact answer, and how many solutions are there? There are 2, so we should put that in set brackets. If I needed to find the estimate, then I need to substitute these back in. So I need to find in my calculator -1 plus the square root of 33 over 4, and then I'll get an approximate answer. In the calculator, -1 minus the square root of 33 over 4, and I'll get an approximate answer. Go ahead and pause the video, see if you can find that solutions, the approximation to 2 decimal places. What you should get is 1.19 and -1.69. Now, remember we started out with denominators, so we need to make sure that x is not 0 and x is not 2. Since our final solution had a radical in the answer, we can be sure that our answer is not equal to 0 or 2, so we're safe. But remember, when we have those denominators, we need to check for extraneous solutions, denominators, and the power rule. Let's take a look at example 3. In example 3, we're looking at something a little bit different because this is not quadratic. It's raised to the 4th power instead of the 2nd power. So just like example 1, we're going to use substitution to help us solve this. And we are going to say this middle variable needs to become something to the 1st power. So we can call it m. And then we say, okay, then m squared will be p to the 4th. And that matches our first term. So we're going to substitute here. It doesn't matter what variable you use. If you're more comfortable with x, you can substitute x instead. We're going to go from using p to using m. So we have m squared minus 3m minus 4 equals 0. We want to see if we can factor that. Two numbers that multiply to -4 and add to -3 are -4 and 1. So that's m minus 4 times m plus 1. Then m is 4 and m is -1, right? Set each factor equal to 0 and solve for that variable. But our question was not in terms of m. We need to substitute back in from m to p. So I started with m equals p squared. When I substitute m, I find that 4 equals p squared. which means I need to use the square root property. Don't forget your plus or minus. So we have plus or minus 2 equals p. And then our second case is when m is -1. -1 equals p squared. Square root property again. Well, the square root of -1 is I. So we have plus or minus I equals p. Notice we have 4 solutions here. We have plus or minus 2, plus or minus I. Notice also our degree of our original question was 4. Degree 4 can have up to 4 solutions. So p equals plus or minus 2 and plus or minus I. Now only 2 of those solutions are real. However, there are 4 solutions there. All right, let's go ahead and take a look at the next page. We're going to start this page off with a concept check. So I'd like you to pause the video, think about this concept check, think about what we just talked about in that last example. Is the maximum number of solutions that a quadratic equation can have, is that 2? We'll answer this in class. Okay, looking at the next example, again, we're looking at this equation that looks kind of quadratic, but it's a little bit different than what we've seen before. Now, we could follow order of operations, FOIL out our first binomial, distribute into our second term, collect like terms, and then factor, or we can solve it by substitution. So again, looking at what is being multiplied in my middle term. And we'll call that, we could choose whatever letter we want. Maybe we call it z equals x minus 3. And then we say, okay, then what is z squared? It would be the quantity of x minus 3 squared. Now we don't have to FOIL this out because notice that is my first term. So when we're using substitution, if it is quadratic in form, meaning if it actually would simplify into a quadratic equation, when we square our substitution, we should get our first term. So here we're substituting from x to z. So we have z squared minus 3z minus 4 equals 0. Again, that first term is z squared. The second term, I replace part of it with z. And then we say, does it factor? Are there 2 numbers that multiply to -4 and add to -3? Again, that's -4 and 1, which means that this factors into z minus 4 times the quantity of z plus 1 equals 0. Set each factor to 0. So then z equals 4 and z equals -1. That's not the answer to our question. We still have to substitute it back in. So we substitute back from z to x, meaning I start with the z equals x minus 3. And I'm solving for x, so you could actually add 3 here, or you can substitute and then add the 3. I usually end up substituting first. So we're substituting back z equals 4, so 4 equals x minus 3, plus 3 plus 3, 7 equals x. And then also z was -1, so -1 equals x minus 3, plus 3 plus 3, 2 equals x. Now I didn't have any denominators, and I never used the power rule, which means I don't have to check for extraneous solutions, although it never ever hurts to check. But since I didn't use either of those 2 things, I know that x equals 2 and 7. Let's look at part B as well, and then you'll have a chance to try one of these on your own. So again, it looks kind of like a quadratic equation. However, my exponents are not quadratic. So I'm going to take my middle variable, and we're going to call it something else. We're substituting. So maybe we say that a is x to the 1/3. Then what we need to look for is what is a squared, and we're hoping it matches our first term. Well, if a is x to the 1/3, then a squared is x to the 1/3 squared. Power to a power, I multiply the exponents. So that's x to the 2/3. So we want to substitute. We have our equation in terms of x, and we want to change it to a. So we're substituting. This is a squared, and this is a. a squared minus 5a plus 6 equals 0. Can it factor? Are there two numbers that multiply to 6 and add to negative 5? Yes, negative 3 and negative 2. So we have a minus 3 times a minus 2 equals 0. We've been quite lucky with these examples that they factor nicely, but remember the last two sections that we've done in class are how do we factor if it doesn't factor, how do we solve it? And that is completing the square and the quadratic formula. So we set each factor equal to 0. And then we have to substitute back in because the question isn't asking for a, it's asking for x. So we go back from a to x. And we had that a is x to the 1/3. So we have 3 equals x to the 1/3 and 2 equals x to the 1/3. Now we have to use the power rule, which means we will need to check our answers. To the third power, to the third power, and we'll do the same to the other equation. 3 to the third power, 3 times 3 is 9, times 3 is 27, equals x to the 1/3 times 3 is 1. That's why we raised it to the third power. And 2 to the third power is 8. And those are the answers that we want to check. So we want to know 27 to the 2/3 minus 5 times 27 to the 1/3 plus 6. Does it equal 0? Well, 27 to the 2/3 is the cube root of 27, which is 3, squared. 9 minus 5 times the cube root of 27 is 3 plus 6. 9 minus 15 plus 6. 9 minus 15 is negative 6 plus 6 equals 0. So it checks out. And then we're checking our second one. So again, 8 to the 2/3 minus 5 times 8 to the 1/3 plus 6. Does it equal 0? Well, the cube root of 8 is 2, squared is 4, minus 5 times the cube root of 8, which is 2, plus 6. 4 minus 10 plus 6. 4 minus 10 is negative 6, plus 6 equals 0. And so they both work. So our answer is x equals 8 and 27. Okay, what I'd like you to do is pause the video, do the try this, and then one of the nice features of Edpuzzle is that it's going to have you type in the solution that you get so that I can see where we're at with this process. So do the try this, type in your answer to Edpuzzle. All right, so now that you've had a chance to do the try this, I will show you both methods, both by substitution and the longer method, which is to actually like distribute everything out and then solve it that way. So first, let's do substitution. We say our middle term has an x plus 2. So let's let a equal x plus 2. Then a squared is x plus 2 squared. So what we have here is a squared minus 2a minus 3 equals 0. What two numbers multiply to negative 3 and add to negative 2? That's negative 3 and 1. So we have a minus 3 times a plus 1 equals 0. A equals 3. A equals negative 1. But the question wasn't about a, the question is about x. So that tells us we need to substitute back. Since a equals x plus 2, we say 3 equals x plus 2 minus 2, x equals 1, or negative 1 equals x plus 2 minus 2, x equals negative 3. I did not use any denominators and I did not use any power rule, so x equals negative 3 or 1. Okay, method 2 is by distributing everything. So first we FOIL x squared plus 2x plus 2x plus 4. Then we distribute the negative 2, minus 2x minus 4 and then minus 3 equals 0. X squared, 2 plus 2 is 4, minus 2 is plus 2x, plus 4 minus 3, minus 3 equals 0. And then notice this is very similar to what we have here. So we would, again, what two numbers multiply to negative 3 and add to 2? So this time we need a positive 3 and a negative 1. X plus 3, x minus 1, x equals negative 3, and x equals 1. Okay, so this shows you, again, you can do it both ways, and in this case, distributing it out was not too bad. That first step has actually multiple things going into it. We have to make sure we FOIL, make sure to distribute the negative 2 properly, but then collecting like terms and factoring was not too much work. So in this case, it looks like that would be the easier method, but usually the substitution ends up being a little bit easier. But it's up to you. You can use either method. Okay? The last topic of this section is word problems. It's applying what we know. So again, we're going to look at finding work time. So remember, we've done this before. And the way we did it before is we looked at if person A takes A hours, or person 1 takes A hours to complete a job, then that person can complete 1 over A of the job in 1 hour. So kind of using that idea of reciprocal. So 1 over A for person 1, 1 over B for person 2, and 1 over X for the two of them together. And we're going to be using that same setup for the next word problem. So let's take a look at the next page. On the next page, example 5, together, an experienced word processor and an apprentice word processor can create a Word document in 6 hours. Alone, the experienced word processor can create the document 2 hours faster. So notice this is not, it doesn't take him 2 hours or her 2 hours. It takes that experienced word processor 2 hours less because they were 2 hours faster than the apprentice word processor. Find the time in which each person can create the Word document alone. So our first step for a word problem, once we understand what's happening, is to define our variables. So I like to use variables that can represent the people in my word problem so that it's easier for me to tell who's who. So I'm going to say E is the amount of time for the experienced word processor. You can use X if you prefer that. And then A for the amount of time for the apprentice word processor. And then together, maybe T, for together, they take, and we know that one as a number, 6 hours. So what do we know? Well, we know that the experienced word processor takes 2 hours less than the apprentice, or that the experienced word processor is 2 hours faster. So we can say however long it takes for the apprentice, E is 2 less than that. E should be smaller. So A minus 2 equals E. E is smaller. Okay. We also know that relationship of work time, 1 over E plus 1 over A equals 1 over T. Well, here we said T is 6 hours, so we can replace that as 1 over 6. And then we don't know A, but we do know E is A minus 2. So 1 over A minus 2. Okay, that's not the only way to set it up, but that's the most similar to the way that we've done before. And now we have this rational equation, and in order to solve a rational equation, we want to clear denominators. So we're going to multiply this by the LCD. What is my LCD? Well, I need a minus 2 for my first denominator. I need a for my second denominator. Notice I don't have a factor of a here. And 6 for my third denominator. So I actually end up multiplying by all three denominators. So this is 6a times a minus 2, 6a times a minus 2, distributing it to each term. 1, 2, 3 terms. A minus 2 reduces, so we have 6a plus, just the a reduces, 6 times the quantity of a minus 2 equals, and just the 6 reduces, a times the quantity of a minus 2. I'm going to go ahead and move the camera down. So at this point we have our equation, we need to solve it. Let's start by distributing. 6a plus 6a minus 12 equals a squared minus 2a. Let's collect our like terms. So 12a minus 12 equals a squared minus 2a. And notice this is quadratic, so we have a decision to make. Do I want to bring all of the terms to one side or leave the constant on the other side? So am I going to factor, complete the square, or use the quadratic formula? So again, our first step should be to move everything to one side. So minus 12a plus 12 minus 12a plus 12. 0 equals a squared minus 14a plus 12. Does it factor? Well, are there any factors of 12 that add up to 14? I don't know off the top of my head, but I can tell immediately my biggest factors are going to be 1 and 12, which only have a sum of 13. So this is not going to work. What that means is that we need to use either completing the square or the quadratic formula. Now, it's up to you which one to use. However, I would recommend quadratic formula just because of the way we already have it set up. So we have a equals 1, b equals negative 14, and c equals 12. And so we can do x equals negative b plus or minus the square root of b squared minus 4 times 1 times 12 all over 2 times 1. Let's get that over. Which equals 14 plus or minus the square root. 196 minus 48 is 148 over 2. X equals 148 factors into 4 times 37. Okay, so the 4 can simplify. 14 plus or minus 2 times the square root of 37 over 2. Okay, now I didn't really need to factor that out, but I'm hoping that the 2 will reduce. And here I can see that the 2 goes into 14 7 times, and the 2 will reduce with the 2. So that's nice. X equals 14 over 2 is 7, plus or minus 2 over 2 is 1 times the square root of 37. So I'm dividing each term. Terms are separated by addition or subtraction. And so here I have two answers. Let's go ahead and estimate them because we want to know how much time it takes for the word processor. So x equals 7 plus the square root of 37. We're going to approximate that in the calculator. And x equals 7 minus the square root of 37. Again, approximate that in the calculator. So our first one into the calculator is about 13.1, and our second one is 0.9. Okay, well, let's go back and look at what this answer means. X is the variable that we had in our quadratic equation, so really x is a, because that's the variable in our quadratic equation. So can a be 0.9 or can a be 13.1? Well, a is the amount of time that it takes for the apprentice, and the apprentice takes 2 hours longer than the experienced word processor. So it can't be 0.9 because there isn't an amount of time that's 2 hours slower than that. It would have to take the experienced word processor a negative amount of time. And so we know that the apprentice takes 13.1 hours, and the experienced takes 2 hours less than that, would be 11.1 hours. Okay, so again, you could type it into your calculator all the way back here, okay? But remember, the plus and minus are two different calculations, and then you have to be careful with your parentheses, okay? Or you can simplify by hand, and this is much easier to type into your calculator. Let's take a look at the last example. So Beach and Fargo are about 400 miles apart. These are places. A salesperson travels from Fargo to Beach one day at a certain speed. We don't know the speed. She returns to Fargo the next day and drives 10 miles an hour faster. Her total drive time was 14 2/3 hours. Find her speed to Beach and her return speed to Fargo. So I'm going to draw a little picture. Here's Beach, here's Fargo, and we have two trips. We have the trip to Beach and the trip to Fargo. We know that the distance here is 400 miles. So that tells me this is a distance, rate, and time problem. So we have rate times time equals distance. But this is not a current problem. I don't have a boat going up and downstream or an airplane with headwind. I have to Beach and to Fargo are my two trips. Okay, what we know from that first sentence is that the distance between these two cities is 400 miles. We also know that we don't have a rate given. We don't have any speeds given. We have a difference in speeds given, that 10 miles per hour faster. So what is my unknown? My unknown is the speed. So we're going to say x is defined as the speed. And then what do we know the least about? We don't know anything about the speed from Fargo to Beach. So the speed to Beach. And that means r, my rate to Beach, is my value of x. The rate to Fargo is 10 miles per hour faster. That's going to be plus 10. So I know my rate to Beach plus 10 is the speed or the rate to Fargo. Okay, so this speed is x, this speed is x plus 10 miles per hour. Okay, and then the time, well, I don't know how much time either trip took, but I do know that the total time, when I add these two up, the total time is 14 2/3 hours. Well, we don't really like mixed numbers because they're not easy to do computations with. So let's turn this into an improper fraction. I know my denominator will be 3. 14 times 3 plus 2 gives me 44/3. So how do I find the time to Beach and the time to Fargo? Well, we know that distance is rate times time, so time is distance over rate. So I can write this time as distance over rate. Distance over rate. So here's my equation. But remember, I'm going to write this instead of as a mixed number, write it as an improper fraction. So we have the time it took to get to Beach plus the time it took to get to Fargo equals the total amount of time that it took for the whole trip. Now we have a rational equation, which means we want to find the least common denominator and multiply everything by it. So our least common denominator here, we have a factor of x plus 10, and a factor of 3. What that means is I'm multiplying everything here by 3x times x plus 10. 1, 2, 3 terms. 3x times x plus 10, 3x times x plus 10, 3x times x plus 10. And I can multiply just the numerators because of the equal sign. So x reduces, we have 3 times 400, times x plus 10 plus x plus 10 reduces 3x times 400 equals 3 reduces 44x times x plus 10. Now let's simplify. 3 times 400 is 1,200. So we have 1,200x plus 12,000 plus 3 times 400 again, 1,200x equals 44x squared plus 440x. Collecting like terms. Let's bring everything over to the side with the x squared. So 12 and 12, so 2,400x plus 12,000 equals 44x squared plus 440x minus 2,400x minus 12,000 minus 2,400x. So we have 0 equals 44x squared minus 1,960x minus 12,000. Okay, now these are really big numbers, so is there anything that goes into all of these? Well, I notice 4 goes into 44, 4 goes into 60, 4 goes into 100. So let's try dividing everything by 4. Divide everything by 4. 0 equals 11x squared minus, divided by 4 gives us 490x minus 3,000. Very nice. Now 11 doesn't look like it would go into my other terms, so that's as small as we can get it. Now we have a equals 11, b equals negative 490, c equals negative 3,000. And we want to know, does this factor? Probably not. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, now I'm going to put this directly into the calculator, one with a plus, one with a minus. And luckily, what we get here is a positive 50. That's a nice number. And for the subtraction, negative 60 over 11. Well, I know my speed can't be negative, so that's extraneous, which means x, which was the speed to beach, is 50. So then how do we find the speed to Fargo? Well, the speed to Fargo is x plus 10. X plus 10 equals 50 plus 10, which is 60. So the speed to beach was 50 miles an hour, and Fargo was 60 miles an hour. All right, make sure you take a second to digest that, think it through, write a sentence or two, and at the beginning of next class, we'll go over that concept check and we'll talk about our sentences. If you have any questions on the notes video, there's a link to a Google Forms that's posted on the Blackboard page. Please make sure to use that to submit your questions ahead of time so that I can make sure to answer them during class, during our virtual class. All right, if you have something that you'd like to have answered sooner than that, you can either schedule office hours with me or send me an email.